Hey, welcome back, guys. It's been a couple days since we had one of these. Um, so we've already went over the first page in class. So now we're gonna go talk about the next one coming up. Microphone is on. Good. So the first question is really just a general question. The A, B, C, and D is coming from the first question. Okay. So we'll just skip on down to A. So A says, which formula can we use to find AB? Okay, so it says find AB. Well, when it says you to find AB, it wants to know how long is it. And if you're looking for something how long it is, you need to use the distance formula. Okay, and you can do that on your own. You know, skipping in your A and your B. So you have your A is 1/6. Your B is 3/1. I tell you what, go ahead and pause it for a second. I'm gonna come back with the answer. Um, come back with it worked out with your answer, and then I'm gonna start talking about letter B. And if you need to pause it and look at the answer, see what it did, do so. Okay, so I'm moving on to the next one, which is the B part. Okay, again, you can pause and check to see what I did. That's just me using the distance formula and getting the square root of 29. So what bisects AB? Okay, well, remember, bisect means split into two equal parts. I'm hoping you guys would know that by now because we have talked about it, and I've asked you over and over and over again what bisect means. Splits into two equal parts. Well, taking something that's split into two equal parts is basically you finding the middle. And if you're trying to find the middle, or the point that's in the middle, then you need to find the midpoint. And remember, that is x1 plus x2 divided by 2, and then y1 plus y2 over 2, and that's the middle. Okay, pause it again. I'm gonna come back with the answer and go into letter C. And you'll notice that the B portion, or the B, the midpoint is 2 square root 7. And you'll notice my work is there as well. Okay, so now the next part, it starts talking about the slopes that show that the measure of ABC is a 90 degree. Okay, now to show that, we can find slopes. Remember, things being perpendicular. When things are perpendicular creates a 90 degree angle. Okay, now we know that by using their slopes. Okay, if you remember, a perpendicular slope is the negative reciprocal of another slope. Okay, and in parentheses, I'll tell you, it basically means, remember we talked about it means opposite and flip. Okay, that means the opposite meaning opposite sign. So if it's a positive, the opposite is a negative. If it's negative, the opposite is a positive. Okay, and when we talk about flip, that means flip the fraction. Okay, so the question might be is, what if it's not a fraction? Okay, so we have the number 4. Well, that's like saying 4 over 1, so the flip of that would be 1 over 4. That would be the flip version of that. Okay, so remember, opposite and flip on that. Okay, I'm going to pause this, or I want to pause this. I want you guys to kind of pause it and work it out a little bit, see if you can get the same as what I did. Okay, and you'll notice I did the AB slope in black, and my answer was -5 over 2. Then I did the BC slope in green, and I got 2 over 5. Is that opposite and flipped? Yes. The one in black is negative 5 over 2. The opposite and flipped, so the opposite would be a positive, which is what we have here. Nothing's working. Is the opposite, which is a positive. Then the flipped version would be, instead of 5 over 2, it's 2 over 5. So yes, that is the opposite and flipped, or the perpendicular slope of each other. Okay, now, the one that shows you below, it says, for you to try, it says, given ABC, what is the length of the line segment connecting the midpoints of AC and BC? Okay, what it's asking you is, you're looking for the midpoint. Okay, you're looking for the midpoint of okay, this one's going to ask for a lot of work on this one, but what it's asking you, you have the midpoints of AC, which is, I don't know, somewhere in that area right now. I haven't, I'll do the work here in a second. And BC, which is right here, somewhere around that area. What it's asking you for is, what is the length of this line here, okay? What is the length of basically that mid-segment is what it is, basically. It's a mid-segment. So the first thing that you would have to do is, oh my gosh. All right, so the first thing you'd have to do is find both midpoints. And that means BC and AC. So after you find the midpoints, the second thing you need to do is find the distance with the two midpoints. Okay? So do the first thing, find the midpoints, then take those midpoints and do the distance formula. Okay? And then pause, come back. I'll come back with the answer. Yes, I know, I understand it's a lot of work just for something like this, but at the same time, you're getting older. That's what you end up have to do. A lot more work to find things, okay? Things get harder, you have to put a little more work into it, okay? But pause it, do the work, come back. All right, so here's all the work. In the brown, I've got your midpoints, okay? So here's your midpoints for AC, and here's your midpoints for BC. I took those midpoints and put them down here in the distance formula, and then I found the distance. So after I plugged everything in, I found the distance to be 7.29. So back to what I was showing you before, these areas here, whatever the mid-segment is, it's going to be the square root of 7.25, okay? So that would be your answer for that particular question. It says, what's the length of the line, the segment that connecting the midpoints of AC, BC? That's what that is. All right, so this next example is basically showing you or asking you to try to figure out whether this is the scalene, isosceles, or equilateral. Okay, so remember a scalene triangle, no sides are congruent. Isosceles, 2 sides are congruent, and an equilateral, all 3 sides are congruent. So to figure out what this is, basically is to figure out basically what you have to do with all sides to try to figure out if it's equilateral, isosceles, or scalene. You'll have to do the distance formula for all sides of the triangle. Okay, so basically that means you'll be doing the distance formula 3 different times. Okay, so one of the things you'll do is you'll find x, y. You will find x, z. And then you'll also find zy. You'll find all 3 of those. Once you find them, you'll start comparing. And then once you compare, you'll notice that you'll see if the sides are the same, not the same, things like that. Okay, so I'm going to pause it, do the work. I encourage you guys to possibly try to do all of them yourself as well, just to see if you know what you're doing and things like that. Okay. So I did the distance formula 3 times in a row. Now I'm basically showing that so I basically looked over here and noticed that none of these are the same. Since they're not the same, this is going to be a scaling. Now, the next question asks you if it's going to be a right triangle. Well, if it's a right triangle, we can always use Pythagorean theorem. Doing a Pythagorean theorem. So then we look over here to the right, or look back to the previous question, we notice that this is the largest one, the square root of 65. So that one is going to be your C. So now we can do the A squared plus B squared equals C squared. So we plug that in. So we square root of 52 plus the square root of 13 is equal to the square root of 65. And all of these are squared. Okay. So basically what you can do is you can, if you actually work this out, you'll notice that they will end up eventually equaling each other. Okay, they'll both equal 65 is equal to 65. So yes, this is a right triangle. Okay. So you try the next one on your own. And then I'll probably come back with a different video to show that.
Oh, like, what do I need to take my pants off in front of the nerd?
Dude, there's a bathroom in there. There's a bathroom.
Oh, yeah, there's that.
No kissing over there.
Turn your phone or turn your chair.
Oh, yeah.
Did he actually go?
He's walking like this.